All right. So today we're talking about slope slash rate of change. So first we're going to start by kind of defining what that means. Then we're going to talk about kind of what it looks like in what we're going to be doing today. Okay. So first and foremost, okay, slope, rate of change. Let's see here. We got purple. All right, so we're good to go. All right. So slope slash rate of change. What this is essentially, just to kind of make a very simple definition for you, it's the change in y relative to the change in x. It's the change in y relative to the change in x. So what does that really mean, though? So let me give you an illustration. Let me draw you a picture here. So let's draw somewhat of a really crappy graph to sort of give you an idea. So let's say that x is minutes, and let's say y is feet. All right. So let's say I'm going to graph someone's pace, walking pace over a period of time. So we'll say 1 minute, 2 minutes, 3 minutes, 4 minutes, and so on, right? And then we'll go maybe by like 50 here. 50, 100, 150, 200, 250. Okay. So let's say 1 minute they've walked 50 feet, right? In the second minute, they've gone 100 feet. In the third minute, they've gone 150. In the fourth minute, they've gone 200. Okay? So we have this line. Now, the rate of change is the slope of this line. Now, we've talked about slope before. We've talked about rise over run. You guys might remember when we refer to slope, we think of rise over run. But let me give you, let me explain why we have the definition as the change in y relative to the change in x. So let's say I want to find the slope of this line. Now, I'm going to pick 2 points. In this case, because it's a straight line, it doesn't necessarily matter which 2 points. But sometimes you get questions that ask you specifically the slope of the line between 2 and 3 minutes, or the slope of the line between 1 and 4 minutes, or something like that. So I'm just finding the general slope here doesn't really matter in this case, because the slope between every point here is going to be the same, since it is exactly a straight line. But let's say I take the point 2, choose a different color. Say I take the point at 2 minutes and at 4 minutes. Let's say I find the slope between those 2 points. So what I'd be doing is I would first find the change in y. The change in y. So there are 2 points to consider, and they have 2 different y values. Zoom in on this. So the second point has a y value at 200, right? And the first point has a y value at 100. So the change in y is going to be the difference between this 200 and this 100, right? So to find that, we would do 200. Well, let me actually write this out. So change in y, which is also denoted as like delta y. You might see like a little triangle like that. It's also, that means the same thing as change in y. Change in y, which is 200 minus 100, because that's the second y values, or the second point's y value, and the first point's y value, right? So that makes the change in y equal to 100. Now we have to find this relative to the change in x. So the change in x, same idea. We go to from our second point. So our second point being, there we go. Second point being at 4 minutes. So its x value is 4. And the first point's x value is at 2. So when I talk about change in x, or delta x, I'm talking about the change from 4 minutes to 2 minutes. So 4 minutes to 2 minutes. The difference between 4 minutes and 2 minutes is just taking the difference between 4 and 2. 4 minus 2 is 2. So, in a sense, the reason why slope is referred to as rise over run is because rise represents the change in y, delta y, and run represents the change in x, delta x. So change in y over change in x, or change in y relative to the change in x. So in a sense, our rise, if you look back at our graph, our rise would be going up 100 because it's my change in y. And my run would be 2 because that's my change in x. So it's my change in y over my change in x, which is 100 divided by 2, or 50 over 1, which is the same thing as just simply 50 as my slope. So this is referred to as rate of change. Now, in the context of this problem, this means that this person walks at a rate of 50 feet per minute, right? It's still a rate. It's the rate. It's called the rate of change because it's their pace. It's the rate at which their distance changes. Their distance is changing by 50 feet every minute, right? They're walking at a pace of 50 feet every minute. So their distance changes 50 feet every minute. So there's your rate of change. Now let's talk about the slope formula. So technically, we've sort of already done the slope formula, but our slope formula is m equals, because m is always the letter that represents slope. So just keep that in mind. M always represents slope. Okay. It's y2 minus y1 over x2 minus x1. So you'll notice this is very similar to essentially what we did over here. 200 minus 100, 4 minus 2. Because we took the two y values and subtracted them, and we took the two x values and subtracted them. So that's essentially what we're doing. We're finding the change in y, subtracting the y values, over the change in x, which is subtracting the x values. Now, it's very important. The main thing here is not to get them mixed up. I don't mean by mixed up by putting the x's on top by accident and the y's on bottom. That is something you want to avoid. You don't want to do that. But I'm talking about accidentally doing something like this, y2 minus y1 over x1 minus x2. Okay, now you might be wondering why those 2's and 1's matter. Well, if you go back to our example up here, right, notice for both of these, we started with the second point, right? Hence the 2 part of our notation. The 2 just means the y value of the second point and the x value of the second point. We started there for a reason. We're starting at the same point. We're always taking this point and then subtracting that previous one, right? So I'm taking the 200 first and then subtracting the 100 from this other point. Then I'm taking the 4 first and subtracting the 2 from the first point, right? So I'm always starting with whatever y value or x value is here and then subtracting this y value or x value from it, okay? So what you don't want to do is take, for example, the y value here first, right? And then this one second, and then since being like 200 minus 100, but then taking this x value first and then doing this x value second. In a sense, you'd be doing 2 minus 4, right? So notice on the top here, 200 minus 100, the 200 comes from what I consider 0.2. We'll call this one 0.1, 0.2. But on the bottom, I'm starting not at 0.2, I'm starting with 0.1. So you don't want to do that. You want to, if you're starting at 0.2, then both numbers should begin with the y value should be from the 0.2's y value, and the x value should be from the 0.2's x value as well. That seemed like a little bit of a ramble. I apologize. All right, anyway, let's carry on. You'll see what I mean when we get further examples done. But anyway, that is your slope formula. Now, what this comes from, just as a reference again, so x1, y1 represents 0.1, and then x2, y2 represents just 0.2. So the 1 in these and the 2 in these don't really make a difference. You're not doing 2 minus 1. You're not subtracting those. The 1 is just here to represent, hey, you're taking the x value from the first point, and the 1 here is taking the y value from the first point. It's just there to indicate which set of ordered pairs you're taking it from. Okay, same thing with these 2's. This 2 just means the second point's x value and the second point's y value. So let's look at an example. Maybe that'll help you understand a little bit better. So, example. All right. So example, let's say we have the point 5.8. Oh man, things lagging again. Okay. 5.8 and okay. I apologize for this. It happens from time to time. 5.8 and 9, -2. 9, -2. So let's call this point 1, and we'll call this point 2. If that's the case, then this is the x1 value because it's the x value of the first point, and this is the y1 value because it's the y value of the first point. And that makes 9x2 because it's the x value of the second point, and -2 would be y2 because it's the y value of the second point. So now if you're just using your formula, right, your formula was y2 minus y1 over x2 minus x1. Then y2 is -2, y1 is 8, so -2 minus 8 over x2, which is 9, minus x1, which is 5. All right. Again, apologize for the handwriting there. It's a little laggy. Okay. So that gives us, if we simplify this, -10 over 4 as our slope, which simplifies to, if we can reduce that by 2, -5 over 2. So -5 over 2 is our slope. All right, let's try a second example. There we go. My pen seems to be working a little bit better. Example 2. So let's look at the point -311, -311, and 221. Now, it doesn't actually matter which one of these you call point 1, which one of these call you point 2. Let's prove it. Let's say this one's point 2 and this one's point 1, right? That makes this x2 and y2, and this makes x1, y1. Again, that x value first point, y value first point, x value second point, y value second point. So if we use our formula, we're going to have y2 minus y1, which is, okay, so y2 minus y1 over x2 minus x1. y2 is 11 minus y1, which is 21, over x2, which is -3, minus x1, which is 2, so minus 2. So when I simplify this, that gets me -10 over -5, which makes this answer simplify to just a +2. So the slope of this line is +2. Now, just to show you, right, let's rearrange this. Let's say that was point 1 and this was point 2, right? So that makes this now x1, y1 and x2, y2, right? So let's say I actually called the points the opposite. Will it still give me the same slope? The answer is it should. So let's do that. So y2 in this case now is 21, and the y1 is now 11. So 21 minus 11 over x2, which is 2, minus x1, which is -3. So we're subtracting a negative. Be very mindful of that. You're always subtracting in the formula. The formula has subtracting in it. you'll notice it's always minus, right? That's part of the formula. This simplifies 21 minus 11 is 10, and 2 minus negative 3 is really 2 plus 3, which makes 5, which 10 over 5 reduces to positive 2. Again, same result. So it doesn't matter which one you call point 1 or point 2, but here's the mistake that I was trying to allude to earlier that I need you to avoid. Okay, so let's say I did 21 minus 11 on the top. That means I'm referring 21 as I'm using my second point first, right? And then 0.1 second, right? So the 21 is coming from 0.2, and then 11 is coming from 0.1. But I can't then on the bottom put negative 3 minus 2. So notice the negative 3 comes from 0.1, and the 2 comes from 0.2. You see how I've mixed them up? On the top, I start with a value that comes from the second point. But on the bottom, I start with a value that comes from the opposite point, right? Not the same one. That's a problem. That's where you're going to get something wrong. If you solve this, you'll end up actually with ultimately negative 2 as the slope instead of positive 2, which is incorrect. So what you need to make sure of, it doesn't matter, as we've proved here, it doesn't matter which point you call point 1 and which one you call point 2, because either way, you'll get the positive 2 slope here. What you need to make sure of, though, is that if you start with one of the points on top, you have to start from the same point on the bottom. So you notice 11, negative 3, both of those on the top and bottom start with that point. 21 and 2, they both start with this point. You can't do, for example, like I just had it, where 21 and negative 3 here are coming from different points. 21's coming from point 2, negative 3 is coming from point 1. They have to start from the same point. Doesn't matter which point you start with. Okay, you can start with this point here. You can start with this point here. All right, negative 3, 11, 2, 21. Doesn't matter which one you start with, as long as you don't mix them up. Okay, where you do one on the top and then differently on the bottom. Okay. How much time do I have left? All right, a few more minutes. All right. So just going to jump ahead real quick. Identify the slope of these lines. So now we're just going to do something easier. Identify slope. So I'm just going to give a few lines here. We're going to identify the slope of them. So we have y equals 2x plus 5. We have y equals x over 4 plus 5. And we have y equals negative x plus 5. So identify slopes coming from y equals mx plus b. This is called slope-intercept form. So two main things to be aware of here is the m and the b. The m is your slope value. The b is our y-intercept. Now here it just says identify slope. So we're looking for the m value of every point. Now each of these is already written in y equals mx plus b form. Mx plus b, mx plus b, which should make this rather easy, right? On A, we see that the m value is 2. M equals 2. So therefore, the slope is 2. Now, on B, it's a little different because it's x divided by 4. Or another way of seeing it is 1/4 times x. So it's the same thing as x divided by 4, showing us that the m is 1/4. Thus, the slope, of course, is 1/4. And the last one, we have the m being just a negative, but that negative is hiding another number. It's really negative 1 times x, showing us that m is negative 1, that the slope is negative 1. So be on the lookout for that as well. All right, now there are different types of slope, okay, as well, types of slope. So we have positive slope. Positive slope is a slope that's increasing from left to right. Or if you read it from left to right, you're going upwards. You have negative slope as another one. Negative, obviously, pretty much the opposite. You're going downwards from left to right. Then you have the zero slope. So zero slope just means directly straight horizontal, right? Basically flat ground. And then you also have undefined slope. So undefined slope is another straight line, but it's going straight up and down rather than side to side. Okay, that's undefined. So you have those 4 types of slopes to be aware of. All right. I think I'm going to end that video there. That's probably what we got done in class. So hopefully it helps you understand a little bit about slope. It's pretty simple when you really think about it. It's just subtracting a couple numbers. Really not too bad. Just you're going to have to be careful in the future when we read questions. You have to make sure you read them really, really carefully, because if you don't, it could be an issue. But we'll talk about that more in a future video. So I'll see you guys. Good luck. Happy December, by the way. All right, bye.